Next up in Chapter 11, we have transformations. Now, if whenever you hear transformations, you think of this guy, you're not really that far off. Transformations in the pre-algebra world are just taking shapes and moving them or changing them in some way. Now, as you see from the front of your note packet, we do have another good bit of vocab going on in this chapter. So if at any point in time you're not exactly sure what they're talking about, please be sure you come see me. But the good news is I'm not going to have you do a vocab chart. Before we actually get started in transformations, we first need to review plotting points because transformations occur a lot on the coordinate grid. So for the first example, it says plot 3, -4 in the coordinate grid. Now, remember, we have our x-axis that is horizontal and we have the y-axis that is vertical. And we always want to go horizontal first. So if the point is 3, 4, I'm going to start on my origin. I'm going to go to the right 3, and then -4 on the y-axis will take me down to -4. So my point 3, -4 would end up right here. Okay. Go ahead and try the next 6. Again, just plotting points, making sure they go in the right spot. If you want to pause while I go through and place all of these, feel free. My dots will be color-coded so you know which one is which. Okay, hopefully your dots ended up in the same spot, and if not, it's probably just a matter of flipping where your X and your Y should be. So if you have a question, just make sure you call me over. In addition to plotting points, we can plot points so that we create an actual shape in our coordinate plane. So for example 2, they're giving us the vertices of quadrilateral are given for A, B, C, and D. Draw the quadrilateral in the coordinate plane. Now the first thing, if you notice, is that you want to plot and label the vertices. If you don't label them, you won't know which one's which, and then when you go to connect them in order, you're going to have some trouble. So for the first one, point A, they're telling us that it is at 1, 5, so I'm going to go over 1 up to 5. Make sure I'm labeling this as A. It's a little chunky, but that's okay. For B, I have 2, 9, so again, going up here, again, labeling it as B. C, 6, 8, C, and D, 8, 1. Okay, so now that everything is nice and organized, I can go back and connect them, starting with A, going to B, C, D, and then you always want to go back to the first point. So if you notice, we created a kite. Okay, so just like the last one, if you want to go ahead and try the next one, so this time you're creating a triangle with points J, K, L, go ahead and pause it, and then you can start it up again when you're done. Okay, it's not the prettiest triangle, but it's a triangle nonetheless. Again, making sure that you're connecting in order from J, K to L. Please make sure your points are labeled. Okay, there will be points taken off in the future if you don't. So before we can get started on actually changing shapes, we need to look at how shapes compare to each other. So for 11.1, we're going to define congruent figures and determine if two are congruent. So notice under the key ideas, we've talked about this definition before, but figures that have the same size and shape are congruent. You can kind of think of them, they look exactly the same. So when we have two things that are congruent, like these triangles pictured below here, we have things called corresponding angles and corresponding sides. All corresponding really means is that they match. So as you can see there, angle B and angle E are corresponding because they match. They're in the exact same place. Same thing with these sides AC and DF. They are also corresponding. So within congruent shapes, we have many sets of congruent sides and angles. It just depends on what kind of shape we have. So below here, we're asked to name the corresponding angles and corresponding sides. Notice that before we even get started on the problem, they tell us that the figures are congruent. We always say you can't base things off of looks, but if they tell you are congruent, then you can start going by, which side looks like which. So looking at these first two blue shapes here look to be trapezoids. If I want to name the corresponding angles, I'm going to go by their position. So I can see here if I start with angle A, the angle that corresponds with A would have to be W because, it's in the same spot, the shapes are in the exact same position, so I'm just going to match them up that way. So if I keep going through each angle, angle B would correspond with angle X, angle C would correspond with angle Y, and angle D would correspond with angle Z, and that's all you have to list. Now, when we get to the sides, it's the exact same story. We're looking at what sides correspond, which are in the same position. However, whenever you name sides, make sure you're naming endpoint to endpoint. So, for example, if I want to talk about this side right here, this is side AB. So, AB would correspond with WX. And then I'm going to go ahead and name all the corresponding sides from there. Since it's a four-sided figure, I should have four sets of corresponding sides. So, I'll have BC is corresponding to XY. CD is corresponding to YZ, and then AD corresponds to WZ. Now, all these sides can be named the opposite of what I said, like side AB could really be BA. It just really depends on how you name it as long as you hit all sets of sides. So go ahead and try this one on your own. So I want all sets of corresponding angles and corresponding sides. Now notice that these two shapes are not in the same exact position like they were in the first example, so just make sure you take that into account whenever you're naming the corresponding pieces. Now it's a five-sided figure, so you should have 5 sets of corresponding angles and 5 sets of corresponding sides. So go ahead and pause, and then you can check your answers with mine when you're finished. Okay, so hopefully you have all these sets that I have listed here. Remember, when you go to the corresponding sides, you can have those letters reversed. So for the first example, you could have KJ and RS or some kind of combination. So next we need to be able to identify when figures are congruent, which is actually pretty easy because we know that figures are congruent when their corresponding angles and their corresponding sides are congruent. So remember the tick marks that we used in the previous chapters to mark congruence, or when two things are equal. So in this example here, we can see on the sides, AB has 1 tick mark, as does DE. So we know that those two sides are congruent. And if I keep going, BC is congruent to EF because of the double tick marks, and AC is congruent to DF because of the triple tick marks. Okay, I can also look at the angles, and I can see that angle B and angle E each have that single line going across the angles, which means that those are the corresponding congruent angles. C is corresponding to F, which are congruent, and D is also congruent to A. So since we have all this information, we can say that triangle ABC is congruent to triangle DEF. Remember this symbol right here means congruent to. So if you're trying to draw, because I know it is a little blurry, it's like the little tilde that you would use in Spanish class over an equal sign. So for this first example, they're asking which square is congruent to square A. Explain your reasoning. So if we look at these 3 squares, in square A, we can see that we have 4 sides length of 8. So obviously B, we have side lengths of 9, so B is not congruent to A. Now for C, it has all side lengths of 8, and it's a square. Squares have to have 90-degree angles, so the fact that they're both squares, they both have side lengths of 8, C is congruent to square A. And for your reasoning, just make sure you sum up about the sides being congruent and the fact that all angles would have to equal 90 because it's a square. Last up here, we just want to apply the knowledge of our congruent figures. So we have these 2 trapezoids here, ABCD and JKLM, and they're telling us that they are congruent. So the first question here is, what is the length of side JM? Now for these types of questions, use the naming of the shapes to your advantage, because the way in which they name them actually tells you how they correspond to each other. So if you look at the names here, AB corresponds to JK because those are the first 2 letters in the names. We could keep going and say that CD corresponds to LM, and any kind of pairing we would pull apart from there. So since they're asking about side JM, not only can we tell by looking at it, but we also know by the way in which the shapes are named that JM corresponds to side length AD. So because AD is 10 feet, we also know that JM is 10 feet as well. So go ahead and try these next 3 on your own. If you want to go ahead and pause, but I am going to walk through each of these. So for B, what is the length of side KJ? We already talked about that KJ corresponds with side length AB, and again, we can tell just by looking at it. So since AB is equal to 8 feet, we know that KJ is also 8 feet. For C, just as the sides are congruent, the perimeters of these 2 shapes would have to be congruent as well. So looking at the numbers that we have for ABCD, since the perimeter is 32, the perimeter of JKLM would also have to be 32. And lastly, which angle of JKLM corresponds to angle C? Again, we could go back to the name, or you can just go by the look. These two are in the same exact position, so the corresponding angles are pretty easy to pick out. But if you wanted to look at the name, C is in the same position as L, which if we go to the image is true as well. So C would have to correspond to angle L. And that's it for 11.1.